and the delay, but will now be webinar. This webinar has been recorded. Please use the question on the right hand to ask the questions. Handouts are available in the download section on the right hand side. A webinar feedback form will be made at the end of the session. Please complete this should you need assistance. So for future webinars, webinars, and any questions, please email me, ross.co. So first of all, myself, my name is Joss. I'll be presenting today. I'm Principal Prosthetist of Blatchford's. I have been a prosthetist for 27 years, and I'm still a clinician here in the UK. As well as teaching around the world. And today I'll be talking about Blatchford's vacuum products and sockets. So to start off with, in the introduction, I will give you a brief background of the products I'll be talking about and why we came to be where we are today. I will then speak about the Echelon Vac, a combination of hydraulic ankle with elevated vacuum units. The Silcare Breathe, a liner we developed for the military to manage sweat and perspiration and improve health. And then I will summarise the outcome of this. So the Echelon Vac, first of all, is a hydraulic ankle with an energy storing foot. This is designed to mimic natural ankle motion, okay, allowing the patient to auto-adapt to changing terrain, whether it be walking up or down a hill, small changes in footwear, and this has been shown to be less tiring. On top of this, we have a combination of an integrated vacuum unit that helps maintain volume of the residual limb, okay, and this will actually improve socket comfort throughout the course of the day. The key attributes of this foot is the combination of hydraulic ankle. With the use of the hydraulics, we can actually fine-tune the energy response of the carbon fiber foot module so that we can make the patient more comfortable. This will also allow the patient to stand and walk on uneven terrains and make it easier, less tiring, and more comfortable for the patient, and this has all been proven. On top of this, we have the integrated vacuum units. This works in synergy with the hydraulics and promotes a more secure suspension of the socket, so there's less slippage of the socket on the patient during walk. The stability is improved, and therefore the comfort and confidence of the user is greater. Moving on to the background, why we came here. This unit is based on the hydraulic ankle. The hydraulic ankle has been shown for the amputee to give greater comfort, especially in uneven terrain. It has been proven to enhance knee stability and control by allowing the patient to stand in a more natural and energy efficient standing way. It gives an improved posture, which reduces low back pain. One of the first studies that was completed in this range of products was looking at the even limb loading between different legs. This will actually encourage the patient to offload the remaining limb and spread their weight evenly between the sound and the prosthetic limb, so that the patient will actually feel more comfortable and do less damage to their sound limb. So the main reasons for using hydraulic ankle, the hydraulics give us improved shock absorption. Okay, the viscoelastic response we have, the combination of hydraulic ankle and carbon fiber springs, closely mimics that of normal human gait, and that we have a control working around the energy storing structure to mimic what happens. We have self-alignment such that the ankle will yield into plantar flexion or dorsiflexion, so the patient can stand comfortably when the foot is not in a neutral position. Whereas on a traditional fixed ankle carbon fiber foot, carbon composite foot, the foot is trying to propel you always back to that neutral, so it makes it easier to stand in uneven terrain. The hydraulics give us a greater level of adjustment and control of the energy storing option of our foot, so we can actually fine tune how those carbon composite springs work for the patient and how they want the energy from the foot unit to be returned, stored, or whatever for them. And all of this is following biomimetic principles. The muscles around our joints actually control how the joints work and how we progress over them. This allows us to do the same. And then finally, we have the positional maintenance. Our hydraulic ankle gives you 3 degrees of dorsiflexion and 7 degrees of plantarflexion. This improved dorsiflexion during swing phase reduces the chance of catching the toe by increasing the minimum toe clearance for the patient. It is well known that the musculoskeletal imbalances faced by our amputees also lead to secondary complications. First of all, the patient is always looking around the floor and around them to make sure it's safe to put their foot down, looking for obstacles and looking for trip hazards. This is causing an increased cognitive demand, which means that the patient spends more energy worrying about the environment than an able-bodied person. We know that lack of adaptability in the limb, especially in how the ankle functions on uneven terrain, means that the patient has to compensate for lack of function, and this causes an increased energy expenditure for the amputee. Also, lack of adaptability of the limb means that because the foot will not move to a natural resting position, it moves the load lines away from the ankle, knee, and hip joint when the patient's standing. This will lead to uneven standing, especially in the lower lumbar area, and cause low back pain for the patient. Unequal limb loading, which leads to joint pathologies, is a well-known problem in lower limb prosthetics. We've been talking about overuse theory now for a long period, where our patients are forced to compensate with their sound limb for lack of adaptability in the rigid energy storing foot on the prosthetic limb. By using a hydraulic ankle, we allow the ankle to self-align to whatever position the patient's standing in. This restores balance and improves and encourages more even limb loading. So when we look at it, the hydraulics, how they work together with each other. Okay, so the energy storing E-carbon springs, they store and release energy to help propel the patient. And then we have a hydraulic ankle unit that absorbs and gives a greater degree of control to the patient. So by adjusting these hydraulic units, we can actually improve the compliance of the ground, and also we have the ability to fine tune when that energy is returned to the patient and how much of it is returned. So if you have, for example, someone who likes a very stiff spring and then to be propelled forward onto foot flat quickly, this can be adjusted by how the ankle works. Similarly, if you have someone who likes a very soft toe, you can adjust how those carbon fiber springs work to give you a greater degree of control of the prosthetic limb. So here we see a very bad a video of patients. So in the first one, we see the patient walking with a conventional ankle. Okay, he's walking down a hill, and because the ankle doesn't comply to the ground, he actually has difficulty maintaining balance and then reaches for the wall. When he moves onto the hydraulic ankle, because of the adaptability of this, it allows him to walk down the hill, in this case, in a good manner. Here you see one of our technicians, a through knee amputee, standing, and what happens is the ankle adjusts to what is happening underneath him so that he can stand in an even position. So the ankle will accommodate the underlying ground the same as a natural human ankle, and this allows the patient for the first time to stand there on uneven surfaces with a minimum amount of muscle control. This will save energy for them and actually allow the patient to partake in far more activities comfortably. So the Echelon Vac gives you all the benefits of an Echelon hydraulic ankle. This is when research has been done independently from around the world looking at the use of hydraulic ankles. They have all been shown to give you improved comfort, especially in uneven ground, and how they affect the user's socket comfort. We see enhanced stability and that the patient's balance is improved because it allows the load line to pass closer to the knee and hip joint, and this reduces the amount of work they've got to do. And also, when standing on ramps, the amount of work they have to do at their knee is greatly reduced because the ankle accommodates the uneven terrain, so this gives them better knee control. We see improved posture with reduced lower lumbar lordosis, which improves the actual standing of the patient and their posture. As I've already mentioned, we have more even load bearing between the limbs. Because of that improved comfort and improved posture, the patients feel that it's capable to share their load more evenly between both legs, and this will reduce over time joint pathologies in the sound limb. It's been proven in several studies that looking at the hydraulic ankles that while they are more adaptable, they do lead to a more efficient gait, and that patients will have an energy saving as well as a faster self-selected walking speed. Finally, I also want to mention the additional toe clearance. Okay. Because the foot is actually held in a dorsiflex position during swing phase, this will give you an additional toe clearance. This additional toe clearance means that there's less chance of catching the toe during swing phase, therefore stumbling and falling is reduced. So on top of this, what we want to do was to improve the socket connection. Okay, the socket, as you know, I am forever saying, is the most important part of the prosthetic limb. Everything we can do to improve the user's comfort is a major benefit. It doesn't matter how good the limb is. If the socket's not comfortable, the patient won't use it. By adding an elevated vacuum unit onto this, we can improve the user's comfort, security, and stability. Poor socket connection, as you know, means that you will have slippage of the socket. And therefore, that slippage causes shear forces, which will give you the potential for rubbing and chafing, which is a potential source of skin breakdown. Also, as the socket slips and falls off the patient during swing phase, we see reduced ground clearance, okay, which will lead to compensatory movements as the patient tries to make sure they don't trip or stumble. This will lead to a reduced symmetry, an increased risk of falling, but also a reduction in control and a compromised safety for your user, all of which are not looked for. To go over this, we have several suspension techniques currently used. We have the pin lock. In this case, we have a pin that is fixed to the bottom of the liner, and then this engages with a lock that's on the distal part of the socket. Okay. These come in a range of different types, whether they be smooth, ratchets, or clutch locks, and you just choose the one that suits you. But in each case, you have a pistoning and a pulling on the end of the stump. So when elevated vacuum is being compared to pin lock suspension, what has been seen is that the pistoning was reduced by 83% when you compared the elevated vacuum to the pin lock suspension. Okay, and another key study right to the bottom from Italy showed that elevated vacuum decreased the occurrence of volume changes daily for the patient. This maintenance of limb volume means that you're guaranteed a better fit for a longer period of time, and you have less chance of discomfort of the socket and stump breakdowns. Passive vacuum is a technique that I've been using for many years. In this case, we have a one-way valve and a suspension sleeve of some sort. The patient stands in the socket, and then by walking, air is allowed to be expelled from the socket through a one-way valve. This creates a volume. This creates a vacuum inside the socket and allows the patient to maintain the leg. Again, when comparing elevated vacuum to passive vacuum suspension, we see that the reduction in pistoning is reduced by 70%. Both passive vacuum and elevated vacuum maintain a better volume of residual limb loss than is available with a pin and lock. But when you compare passive to an elevated vacuum, we see a reduction in interface pressures of up to 7%. Finally, moving on to elevated vacuum and the reason for this today. Elevated vacuum, maintain residual limb volume. Okay, so by drawing fluid into the residual limb and cutting down pistoning, we actually maintain the patient's limb volume over the course of the day. This means because the volume is not changing, we have greater comfort and we reduce the risk of skin breakdown. By maintaining an adequate socket fit, we reduce the chance of the limb slipping while the patient swings the leg through the air during swing phase. This gives us an improved ground clearance. This gives you a reduced risk of falling through catching the toe, as you have a better toe clearance. Finally, the better coupling of the socket to the amputee with the elevated vacuum has been shown to give you greater proprioception, which gives you greater control and safety for the user. So the Echelon vacuum, what we have is we have the benefits of the hydraulic ankle, giving you greater comfort, greater stability, greater confidence, with an elevated vacuum unit, which will give you greater maintenance of the stump volume, greater comfort, and therefore greater stability inside the socket. As I say, both of these parts built together gives us the Echelon Vac. The Echelon Vac benefits for the amputee are that we know that the lower limb amputee is likely to have 2 or 3 times greater chance of osteoarthritis than knee or hip compared to the general population. And if we can maintain good socket fit in the prosthetic side, it means that the amputee no longer has to overcompensate with their sound limb. This means that we will prevent joint pathologies in the sound limb for longer, okay, and allow the patient to be as good a lifestyle as possible. So the Echelon Vac. Moving on to detail of it. The Echelon Vac is a hydraulic ankle with an integrated elevated vacuum system. The hydraulics, the same as our other energy storing foot with hydraulic ankles, gives you 3 degrees of dorsiflexion and 6 degrees of plantar flexion. Simultaneously, during walking, air is withdrawn from the socket and expelled into the air. Okay, and active ankle motion is what actually draws this air and gives you your elevated vacuum. It's a simple system, there's no power required, and the unit is currently weatherproof. The system comprises the auto expulsion valve. This must be used as a threaded unit that has to be screwed into the socket and creating an airtight seal so that it will allow air, sweat, etc. to be withdrawn from inside the socket out. It's supplied with an inline filter. This is used to make sure that any areas of sock or liner that are drawn by the elevated vacuum are not pulled themselves into the pump. We have the valve block or body. This is a two-way. This is a 2 valve and one. One actually draws air and creates the elevated vacuum. The second valve actually expels that air and any skin, etc., that's pulled into the valve body expelled from the system, protecting the pump itself. And then we've the Echelon Vac foot unit itself. As I say, the valve block or body contains 2 valves, allowing air to be drawn through the unit from the socket down towards the foot, but preventing air moving back towards the socket. This also expels any air or sweat through the distal valve, and it's therefore important that the arrow, as you see in this body here, is always pointing down when in use. How it works: while you're walking, movement of the hydraulic piston controls ankle dampening. So this gives us the control of those springs to maximize the patient's potential. However, in this case, the Echelon Vac, we have a pneumatic chamber proximally or just above the piston, and this is driven by the hydraulic piston. This generates a pressure which actively draws air away from the socket at heel strike. Okay, and this is the elevated vacuum we get. Typically, elevated vacuum generated with this system will reach a maximum of 17 inches of mercury.
Echelon continuously self-aligns, adapting to different terrains, fine-tuning the ankle position for smoother, easier and safer walking, minimising socket pressure for greater comfort. The patented design of Echelon Vac incorporates a pneumatic vacuum chamber that works in harmony with a biomimetic hydraulic technology to generate an elevated vacuum, helping maintain a secure connection. With every step.
Okay, so as the patient walks, what's happening is they land at heel strike, the elevated vacuum is created, and this draws air and sweat away from the socket, and then this is expelled through the system. Okay. Then as they move forward into dorsiflexion, that air or sweat is then expelled from the system. After approximately 70 steps, the patient will reach the maximum degree of elevated vacuum for the unit, and we will see the 17 inches of mercury. When you order the Echelon Vac, it will come complete with the foot, the valve body, the expulsion valve, tubing, and it will also come with a syringe. This is used in servicing and testing the unit to make sure everything's working properly. And we'll show you this in a second. We also have the small blue valve, and this just stops any dust or dirt being drawn into the body. Technically, the unit is suitable for outdoor use. Okay, so unlike the standard Echelon foot, it is not suitable for submersion in water. The unit is only 6 millimeters taller than a standard Echelon, but it still has a maximum user weight of 125 kilograms. Ideally, the Echelon Vac is intended for K2 to K4 users, though it is not intended for running. Okay, so it is recommended for those patients who are looking for improved suspension and those patients who are looking for better control of prosthesis. Okay. There are contraindications, however, for the elevated vacuum. Dialysis patients are contraindicated due to being subject to last systemic shifts in body fluids during dialysis. So these patients are not recommended. Also, the patient should be able to tolerate a total contact socket, as any voids inside the socket may cause problems with elevated vacuum. So we do not recommend elevated vacuum sockets for those patients who you build a void in the socket. It must be total contact. Looking at the scientific evidence from it, the benefits of elevated vacuum for K3 patients has been shown to improve residual limb health. There's a series of very good papers produced, for example, in Italy, which looked at how they encourage tissue health and wound healing for our amputees. They also slow up the period from amputation to actually achieving their preferred outcome measure. They maintain socket fits and control by reducing limb volume changes, and they also reduce pistoning, which will lead to an increased safety and reduction in falls. And elevated vacuum has been shown to improve socket comfort and reduces pain with prolonged use. Fitting recommendations: assemble the filter, the tubing and the valve block. Insert the valve barb into the back of the socket proximally. Okay, so, and then wrap the tubing around the pylon. Each foot comes with plenty of tubing, so this is not an issue. Insert the tubing to the ankle distally and secure the valve block with the prosthesis of the tie clip that is supplied. For best results, have that valve body or block as close to the ankle as possible. The closer to the ankle, then the higher the vacuum that will be drawn. Okay. For the ankle, use the alignment wedge that we use always for hydraulic ankles. Put the foot inside the shoe, set it to its maximum plantar flexion, and then check the alignment line. Okay. The weight line should pass through the crosshairs as marked on the side of the foot. Once you've done this, ask the patient to stand up to check the dynamic alignment, stability. Ideally, when the patient stands, they should find that with minimal muscle effort, they should be able to stand balanced without falling forward or back. Okay. If the socket is too far back or too far forward, you will see the patient falling forward or backwards. The patient should be able to stand quite comfortably without stressing their knee joint or hip joint when standing. Okay. So, valve system check. This is a troubleshooting guide. So, if your patient comes back and says that there's a problem with the system, all you want to do is check to make sure that the leak is maintained. So, first of all, close your suspension sleeve, push it inside the socket till you get the air expelled, and then you should feel a resistance. Okay, as you see here, as you pull it out. Okay, that shows you that the vacuum has been maintained and there's no hole in the suspension sleeve. Holes in the suspension sleeve are unfortunately the most common problem we have, and this is usually caused by damage around the socket edge. Next, inspect the tubing and connections. Make sure everything's tight and well sealed. Okay. Principal joints are at the socket edge and around the valve body. Okay. Make sure there's no holes and everything is engaged properly. Now, you can make sure that the vacuum is being created at the ankle by using a valve gauge or simply by connecting the syringe that's included in the pack. And as you flex and extend the foot, so plantar flexion, dorsiflexion, this will create the vacuum and you should see the syringe move, okay, which is now what's going to be happening here. So as we see, as the foot is plantar flexed and dorsiflexed, the same as it would during walking, the valve is pulled out of the way. Next, check the two valves. Okay, the exhaust valve is at the bottom, okay, which is important because it's marked with an arrow. So make sure this is facing down. Okay, so it should be free to move in one direction, and in the opposite direction, you should see a resistance. Okay. Adjusting the vacuum level. As I mentioned already, the highest vacuum level is achieved when the valve body is positioned close to the ankle. Okay, increasing the distance between the inlet and the valve will reduce the vacuum level if required. So if you have someone who says that they feel that there's too much vacuum being drawn, then if you move the valve further away from the ankle, you will see a reduction in the level of mercury being pulled at the socket. Socket designs must be total contact. As I said before, elevated vacuum is not advisable when you have voids in the socket, as you will cause localized edema in these areas. We recommend a technique that captures bony anatomy rather than just surface topography. Always use a suspension system. Casting guidelines are available, and we have a video of this on the website should you need to look at it. For the suspension sleeve, make sure you trim the socket for greater sleeve durability. Excessively high anterior, medial and lateral walls of the socket will put your suspension sleeve at risk from being damaged, especially if the patient is crawling on the floor or working in confined spaces. There's two typical methods of suspension sleeve being used. The first method, closest to the text, where we actually roll the inside liner back on itself. In this case, the suspension sleeve adheres to the liner as you roll it on, and this creates a good seal. However, some patients find this uncomfortable or too bulky, in which case you want to make sure the suspension sleeve is long enough that it rolls up and above the layer or the line of the level of the liner, so that it engages directly with the patient's skin. Both systems work. Moving on to the socket, the suspension. So current socket techniques use liners that are made from silicone, thermoplastic gels, or polyurethane. These materials are impermeable and they won't allow fluid out. They are insulating materials which keep you warm, and this leads to buildup of sweat in the liner. Vacuum systems expel air from the liner and socket interface. So in this case, we can see an amputee. He's a popular triathlon athlete going for 10 minutes of fast cycling, and we can see the sweat is built up so that the sweat begins to pool out the top of the socket. We know that sweating inside the socket causes the liner to move against them, so therefore they expend more energy. Our amputees have a compromised ability to cool due to the reduced surface area, and you've got to remember at this point it's not just the areas being amputated, but also the area that your liner and suspension sleeve covers. And as I said before, the materials we currently use in prosthetics to manufacture the socket work as insulators. Okay, so these will actually help increase the temperature inside the socket. So from this we have the Silcare Breathe range. This currently includes the locking liner as well as a cushion liner. However, I will talk predominantly today about the cushion liner. This is breathable technology designed for the military to remove sweat from the skin and allow for a more comfortable socket all day. Okay, so the Silcare Breathe liner is a perforated silicone liner designed to expulse moisture for a cooler, drier skin and a more secure socket fit. Okay, it uses a fabric cover which has different areas of stretch that we can control to maximize patient comfort while not restricting knee flexion. The liners are coated with a tenderest coating to reduce shear and make it easier to don and doff, and should be used with a suspension sleeve and expulsion valve. Okay. So here again we see the area from before. We have the socket in red, we have the liner that's put on the patient, and then we have the suspension sleeve, in this case pulled up above the level of the liner so that we have a seal, and then we have an active vacuum or a one-way valve that will pull that air and sweat away from the patient. The holes are drilled by laser into the silicone liner. They are done along the length of the liner, and the evidence for this was collated and done under a military grant, and the evidence was presented at the ISPO International Hyderabad in India. Okay.
The patented technology of the Silcare Breathe liner works by letting air out.
Okay, so the technology is quite simple. During stance phase, pressure is applied down from the residual limb through the socket, and this actually forces any trapped air or moisture against the skin out of the liner and away from the skin, so that it's then trapped between the liner and socket. Then again, at the next heel strike, it is expelled through the one-way valve out of the system, so therefore keeping our patients dry and cooler inside the socket, and also in greater control because we do not have that sweat. More recently, because many people still prefer to use locking liners, we have developed this technology even further, and this involved the Silcare Breathe locking liner. So you can use a pin. The benefits of this procedure is that we still have those laser drilled holes, but they are now above and below the matrix, so that we can control elongation of the residual limb. But we now have this one-way valve on the distal end of it, which closes the valve during swing phase. So air is not allowed to move back into the liner during swing phase, but allows sweat and air to be expelled during stance. So this distal valve maintains the vacuum and actually creates an elevated vacuum on the distal end of the residual limb over the area you would normally have a matrix on a silicone liner. At heel strike, air and moisture is displaced away from the skin, first of all into the socket, and then away from the socket out of the system. The valve is slightly different shape, okay, that because we require some movement of the valve during stance phase to allow the system to work. To allow this to happen, each pack comes with a casting dummy, which is a spacer, which allows you to create the socket shape. Okay, so here you go. In this case, you see heel strike, pressure comes down on it, it pushes sweat and air down against the valve and then out into the socket. The valve closes when weight comes off, and then it stops air from getting into the system. Patient selection criteria for transtibial patients, ideally with good soft tissue coverage, because we have a silicone liner intended for the more active patients. Cognitive ability is of key importance. Cleanliness and cleaning these liners are very important, and the hygiene is of the most importance yet. Suitable for any level of amputee who's looking to control perspiration and reduce unwanted movement. Contraindications are for extremely short residual limbs, especially when using the locking liner. Deep invaginated scarring can act as a reservoir of air inside the socket and can also be a problem. For the pinlock version, distal hypersensitivity to traction or drawing of the soft tissue is a contraindication. And finally, poor hygiene. Because air, sweat, and dead skin particles will be drawn through the laser drilled holes, it's important that your patient can actually clean the liner properly. Otherwise, you will have problems. Instructions for cleaning can be found on the web. The liners available currently in sizes 22 to 40, and either a cushion or locking liner. Looking at some case studies, the first case study, K3 male, regularly exercised, jogging, etc. Sweat used to build up around the scarring, which led to blisters, and he'd been booked in to have surgery. Patient was then fitted with a pinlock perforated liner, and even after a month, the patient mentioned that they had considerably less sweating after jogging, and this was improving socket comfort. By September, the blistering had healed, surgery had been cancelled, and the patient was regularly completing 5-mile jogs. This was a 3-month period. Okay, repeated research into this thing has found that most patients will find that there's a acclimatization period for this, and this will take 2 to 3 months. Case 2, another male involved in motocross events and had continued problems with breakdown of the residual limb. In August 2017, we saw this ulcer develop in the posterior aspect of the patient's residuum. This persisted for over a year. A year later, he was fitted with a Silcare breathe liner. A month later, it was a visible reduction in size. Okay, no longer separating, the patient was beginning to heal. And by October, it was seen to be well, healing, reduction in size, the tissue was granulating and healing, and the patient was then fitted with a cushion perforated liner Silcare breathe with suction suspension. Fitting with suction suspension, passive vacuum, this created better circulation, and then by November, the wound was almost completely healed. At the end of November, the wound, the ulcer, was considered to be completely healed, and the patient was discharged from wound healing. Case 3, chronic residual limb skin tissue issues for more than 8 years. Constantly, patient was coming back with either macerated or infected skin. Patient was in line for revision surgery, and this was considered the last chance. Fitted with cushioned Silcare Breathe and suction suspension. A year later, fitted with elevated vacuum suspension on top of this and a hydraulic ankle with the Echelon Vac. And by November that year, was wound-free with no residual health problems. Okay. Now, patient is still happy with the description and still uses that socket. If you go to our website, you will find that we have a white paper on a study of residual limb health. This will actually give you a group of case studies and the key findings of the information that we have discussed today. Fitting recommendations. The liner size selection, measure the circumference 4 centimeters up from the distal end. Okay, then select the liner from the chart. My recommendations for the volume reduction is 3 to 5% proximally, depending on the soft tissue and the anatomy of the patient, and reducing to 0% distally. Okay. Make sure your measurements are accurate, and make sure you have an effective total contact socket. Cleaning the liner, very simple. Wash with simple soap and water. Okay. Put soapy water inside the liner, squeeze, and then you'll see the water being expelled out through the small laser drilled holes or valves. Okay. Rinse well, pad dry. Clean with alcohol spray is required, or something like a baby wipe once a week, and this will get rid of any odor. In summary, the biomimetic hydraulic ankle with integrated elevated vacuum system, the Echelon Vac, has been designed to reduce the chance of the patient tripping and falling, to improve socket comfort and the pressures generated at the socket while walking over uneven terrain. The elevated vacuum is designed to improve the socket comfort by stabilizing the limb volume. There's no power required, and the unit is independently controlled for plantar flexion and dorsiflexion. Benefits to the user is that by managing to control volume fluctuations in the socket, we decrease their chance of tripping and falling. We improve their proprioception and control of where the prosthesis is at any time. We improve greater socket comfort, stability, and control, and all of this leads to greater confidence and use of the prosthesis, and therefore overall greater satisfaction. In summary, when used as a combined partnership, so when we have the Echelon Vac used with the Silcare Breathe cushion liner, we see cooler and drier skin. We see sweat is driven away from the skin. This maintains suspension and control for the user, minimize pistoning and chafing. Well, this will make the socket more comfortable. It will improve ground clearance. This will promote gait symmetry and reduce energy expenditure for the user. Further information can be found on the Echelon Vac and the use of the Silcare Breathe on our website, where you can refer to our clinical compendium, which is an in-depth look at various papers published promoting these materials and these techniques. And we also have white papers, which are short and simplified versions for the non-clinician, which are handy for patients and funding bodies. Finally, I'd like to thank you for your time and our technical issues today. On behalf of myself, the presenter, John Ross. Please don't forget to complete the feedback and the follow-up. Please register for the next webinar at blatchford.co.uk webinars, and more resources for the clinicians can be found at blatchford.co.uk/prosthetics/professionals. Thank you.